Hello everyone, it's BioDare and I dare you to use it. In this video I'm going to present period analysis in BioDare. If you haven't seen our previous video about data import, please check it out as you might learn a trick or two. So I click New Analysis. First I need to define the data window, which is the time range I want to analyze. 0 here means beginning of the data and 0 here means the end of the data. Normally we want to analyze the longest data range available, but it may not always be possible. Like in this case, I can see the transition effect at the beginning, so I'm going to trim the data and analyze them after 1 day. Generally, with 5 or more days of data, we can get really good period estimates. With 3 days of data, you should be careful how you interpret the differences. And if you have less than 3 days of data and sparsely sampled, you should probably do a rhythmicity test, not a period analysis. The second parameter is the detrending applied before the analysis. By default, it is a linear detrending, and in most of the cases, it is good enough. Like in this example, we can see that the traces are relatively flat, and we can clearly see the oscillations, so this detrending is sufficient. I will make a separate video to discuss more detrending. The next parameters are about the expected period. First of all, it is a range that BioDare will consider as circadian. Here it is defined from 18 to 34 hours, so whenever period values fall in this region, they are treated as sensible and they are averaged for the summary statistics or included in the plots. The values outside this range will not be automatically included in the graphs or the summary table. The second aspect of expected period is related to analysis implementation. Some methods, like for example MESA, scan this period range step by step for the best candidates. For example 18, 18.1, 18.2, up to 34. So the only period those methods can find are within this range. If my data had period 40 hours, then MESA would not be able to return this value using the current setting. However, you don't want to define this range too wide, as you don't want to pick up harmonics or secondary components. This is a good default, but if you have very short or long period mutants, you can shift the range to the left or to the right. The final option is the actual method of period analysis. There are 6 of them available. They are fully described in our paper, or briefly in the BioDare documentation. It is so easy and fast to analyze data in BioDare that we recommend to use at least 2 of the methods. The method of choice for me is FFT-NLS, the classic in the circadian field, and the second method is MESA, which we discovered as very accurate and fast. More importantly, MESA is based on completely different principles than NLS, so they are unlikely to agree just by a coincidence. But of course you can try all the methods, they all have their own strong points. I select FFT-NLS, I press Analyze, and almost instantly I'm getting the results back. Once the results are back, we can look at the period values using box plot. In the box plot, the solid line is the median, the dotted one is the mean, the box itself contains 50% of the values around the median, whiskers points where the outliers would start, and the dots represent outliers. This kind of plots helps you to visualize the distribution of the values, not just the mean. I can sort by the period estimates and see that the PRR79 is the long period mutant and the Y-type is around 24 hours. But at the same time we can see how big is the biological variance in our data, and even if mean is around 24 hours, the individual values are between 25 and 23. I can hide the labels if I'd like to use this plot in a paper. And to use this plot as a figure, we don't have to take the screenshots. We can actually download it in SVG format, which is a standard format, and I could later edit it, for example in Inkscape, and change the fonts, dimensions, or even plot proportions. Phase values I represented using polar plots. The values are plotted around 24-hour circle using circadian time, which means the phases are scaled by their free running period to 24 hours. For example, if my data was peaking at time 15, but its period was 30 hours long, they would be plotted here at 12, so midway through their cycle. Each petal represents one biological replicate. The length of the petal is proportional to the results variation, so the wider the spread, the shorter the petal, like in these 2 groups. We can also see all the individuals at the same time, so you can see the wider spread for PRR79 LHY. There are various methods of phase calculations available. I'm not going to discuss them now, as they deserve their own video. In the meantime, you can check the documentation in BioDare. The phases can be reported to 0, which if you set the offset time correctly during data import will typically coincide with ZT time, like subjective dusk or dawn, or relative to data window, which is when you started to analyze your data. Like with periods, if you like the graph, you can download it and save it in SVG format. Sometimes the petals overlap and it's difficult to see all the groups. We can click on the legend and remove the biogroups we are not interested. Same for the periods graph. There is also access to numerical values. In summary statistics, the results are grouped by biological replicates and averaged. So there is average period and its standard deviation, phase and amplitude values. The phase and amplitude calculation is set using the same switches as for the phase plot. We can also access individual results for each trace: period, phase, amplitude, error measure specific for each method, and goodness of fit, which was our attempt to provide some universal measure, but we are still not completely happy with this metric. We can check individual data trace and its fit. Please keep in mind that not all the methods are fit-based. For example, MESA is not using curve fitting to estimate periods, so the fact that the fit is bad for MESA does not mean that the results are bad. You don't have to examine the results only via web page. You can also download them as a file. First I need to select how I want the phase and amplitude to be calculated, then save it. Inside the file we can find information about the dataset and analysis method, the average values, phases both in circadian and absolute terms, and below all the individual results. You can store this file locally. You would like to have access to your results when you are offline. Another topic I'm going to discuss is period selection. In some of your analysis you may see a warning like this, that some results need attention. What does it mean is that BioDare could not automatically include them in the summary statistics, and they require manual selection. I click Select Periods, and I am presented with a screen that has all individual results. The results that have not been included are on top of the form and marked with red. The typical reason why they may not be included is that the period analysis found more than one periodic component with period value inside the expected circadian range. Here the expected range was 18 to 34 hours. An analysis found one component of 30 hours and another of 22. So both could be considered as circadian, and BioDare could not decide which of the two should be included. We can check the data and the fit. I'm going to hide some of the curves first. We can see it is a good fit, but the signal has trends and non-sinusoidal shape, and the extra components were needed to mimic the shape. For example, the 60 hours was making data higher here and lower at the end. 22 hours wave makes the signal non-symmetrical, as we can see that the curve does not follow the data peaks, while 30 hours curve follows the oscillation of the data, and this is the period we should choose. I can select it directly on the graph, or select it on the form. I save the selection, and after going to the analysis details, we no longer see the warning message. We can also use the selection screen to remove some of the results, for example the outliers. I press ignore, and they will no longer contribute to the statistics. You can see in the summary statistics there are less than 5 biological replicates after the selection. That was all in this overview of period analysis in BioDare. The videos about phases and trends should follow. Thank you, and I will see you next time.